Good morning. Thank you for the opportunity to speak today. I'll be presenting Distintosdispositivosparadistintas, anatomías, and EVAR. In terms of my outline, today I will cover relevant anatomic parameters, relevant device characteristics, and review currently FDA-approved devices for infrarenal, including short neck AAAs, at least within the context of the US. And what you'll see as sort of the theme that I will try to have emerge is that these devices have evolved in response to identified failure modes, such that when we think about which device is right for which anatomy, it calls into question which anatomy is right for EVAR. I have no disclosures. Early generation EVAR devices primarily focused on anatomic considerations regarding feasibility of EVAR versus open repair, so whether or not a patient was a candidate for an endovascular approach, as opposed to truly optimizing which endovascular approach they received. And early design changes reflected some of the early lessons learned. So in terms of advances in graft fabric were made to reduce the porosity that was seen that contributed to endo leaks in the early experience. There were also advances made in terms of delivery systems. They became more hydrophilic and more flexible. There were advances in the profile of the devices. There was now not just standard, but also low and ultra low profile, allowing incredibly small French sheaths to deliver these devices. And that was really intended based on early recognition of the fact that iliac disruption was a real problem with the early generation devices. And really what we learned very quickly in the United States was that there was a massive swing of the pendulum from open to endo strategies, where currently in the United States greater than 80% of infrarenal elective repairs of AAA are performed utilizing EVAR. And this has actually fostered an even greater understanding of device limitations and failure modes. And as time has gone by, a set of device characteristics has been recognized that can be optimized for the necessary anatomic conditions. You really see that the anatomic conditions are mirroring the evolution of the devices over time. So the access vessel stenosis and tortuosity characteristics have been addressed. Issues of aortic tortuosity have been addressed. And issues regarding the neck. So neck length, angulation, diameter, and thrombus burden have all really been addressed in terms of the device evolution in its delivery profile, trackability, conformability, and flexibility, the accuracy of the deployment system itself, the method of fixation, and the range of diameters and lengths that the devices can accommodate. And what we've learned is really that the primary guiding principle is to optimize the device characteristics relevant to the patient's anatomy, which is what we'll talk about today. But I would also argue that there is some hierarchy for prioritization. The devices that I'll cover today are the ones that are FDA approved, at least within the United States. These include the Excluder and the Conformable from Gore, the Zenith Flex and the Zenith Fenestrated from Cook Medical, the Endurant 2 and 2S from Medtronic, the Aor Fix from Lombard Medical, the Trio device from Terumo Aortic, the InCraft device from Cordis or Cardinal Health, and the Alto device from Endologics. The Gore Excluder, this is probably one of the most widely used devices, at least within the US. The C3 delivery system per the manufacturer allows for both precise and controlled deployment. It's a low-profile, highly flexible delivery system, as well as a highly conformable device itself. It does use an active infrarenal fixation system only. And really what you see is that this device has been incredibly well adopted because it's just very easy to use. Some of the instructions for use and the specifications include that the proximal neck diameter it can accommodate ranges between 16 and 32. The neck length has to be at least 15 millimeters, and the proximal neck angulation needs to be less than 60 millimeters. The delivery system ranges between 16 and 18 French. The more recently developed Excluder Conformable allows for increased conformability to adapt closely to the anatomy of the aortic wall, helping to achieve apposition at the proximal seal. There's also reportedly enhanced device positioning with the ability to reconstrain the proximal end for refined positioning. The Zenith Flex from Cook Medical is a slightly different device from both of the Gore devices previously discussed. The Z-Track delivery system allows for precise and controlled deployment. There are variable main body lengths as opposed to the Gore device, and it has an active suprarenal fixation mechanism, unlike the Gore device. Reportedly, there is kink resistance with the widened distance between the spiral Z stents in the iliac legs. In terms of the instructions for use and the specs, they're very similar to the Gore device with a proximal neck diameter that it can accommodate ranging between 18 and 32 millimeters. The proximal length again must be 15 millimeters or greater, and the proximal neck angulation should be less than 60. The delivery system is a bit larger, 18 to 22 French. The Endurant 2 and 2S, this is a device that's incredibly similar to the Cook device. So it's a low-profile hydrophilic delivery system with a tip capture system that allows precise and intraoperative adjustments to be made, similar to the Cook device. Also similar to the Cook device, there's an active suprarenal fixation stent and kink-resistant straight, tapered, and flared limb options. And again, very similar to the other two devices I've described, the proximal neck diameter that it can accommodate ranges between 19 and 32, and the neck length must be at least 15 millimeters or greater. The delivery system also ranges between 18 and 20 French, just as with the other devices. It does accommodate a slightly wider iliac seal diameter. What's unique to this device is that it also has an approved indication for short neck and juxtarenal AAAs with the adjunctive use of the Helio FX endo anchor system. So with the additional use of these endo anchors, which can be placed through the graft fabric out into the aortic wall, the proximal neck length required decreases to between 4 and 9 millimeters in length. Again, nothing else changes about the delivery system. It still requires an 18 to 20 French access. Another deviation from some of the devices I've described previously is the AOR fix. So this device isn't necessarily intended to treat short neck aneurysms, but it does allow for highly angulated necks, up to 90 degrees in fact. It uses this halo stent technology, which is designed to adapt to changes over time according to the manufacturer. And the active fixation is a little bit unusual as well, with a transrenal fish mouth placement described, where the anterior and posterior aspects are at a higher level than the renals, and then the valleys, if you will, on this device are positioned to accommodate the renal orifices. Otherwise, the specifications on the AOR fix are relatively similar. The proximal neck diameter that it can accommodate ranges between 19 and 33, and the neck length, again, is 15 millimeters or greater, but the neck angulation in this case is much more liberal at 90 degrees or less. And the delivery system is 22 French. The Zenith fenestrated is probably, I would argue, one of the most marked deviations from the other designs. This device is approved to treat short neck infra and juxtarenal AAAs. And unlike the other one I described, this is a three-piece modular design with multiple diameters and lengths. It can accommodate up to 3 fens and no more than 2 of the same type of fenestration. So unlike with the other devices that were really seeking to maximize the seal in the infrarenal aorta, this device is designed to bring that seal more proximally to above the level of the renal arteries. And with that, you see that the approved neck length is down to now 4 millimeters or greater for this device. The neck diameter ranges between 19 and 32, as with the other devices, and the delivery system, again, is between 20 and 22 French. The InCraft device is a more recent device from Cardinal Health. Again, very similar to the other devices. It boasts a highly flexible hydrophilic coated system to allow for easy delivery. But what's different here is that it is ultra low profile. So the delivery system in this case is down to 14 French only. The proximal neck diameter is unchanged, 17 to 31. The neck length is a bit shorter than some of the other devices at greater than or equal to 10 millimeters as opposed to 15. But another feature that's somewhat unique to it is that it tolerates a wider range of oversizing, so that fewer device sizes are actually required to accommodate the same overall breadth of anatomy, according to the manufacturer. The Trio device from Terumo Aortic has both a supra and an infrarenal fixation. So again, a little bit different than some of the other devices we've shown. It allows for various main body lengths to be chosen, and you can partially deploy and reposition as with some of the other devices. Interestingly, there's no need to recapture the nose cap, making it a little bit more simplified to deploy it and then get the device back out. The neck diameter, very similar here, 17 to 32 millimeters in diameter, and the neck length being greater than or equal to 15 millimeters for this device. So all in all, this device is not particularly different than many of the other ones on the market, but does have just another set of options available to the user with both a supra and an infrarenal fixation. The Alto device takes sort of a sharp turn in terms of its design and how it's intended to function. So this uses polymer-filled rings to create a seal with the infrarenal aorta. So that's the mechanism by which it seals that at the neck. It boasts a short neck length that's required and the ability to handle conical and reverse taper necks by virtue of the variable polymer filling that can be done. It's also reported to have no long-term radial force, which is a consideration, of course, and one of the hypotheses for why EVARs degenerate over time is the radial force of the seal. It does have a suprarenal fixation mechanism of some variety, this anchor that you see depicted here. The neck diameter is the same as with all the other devices, 16 to 30 millimeters. But again, the neck length is a little bit shorter at 7 millimeters in comparison to 15 for most of these standard devices. The delivery system is also a bit smaller at only 15 French. So I would explain now that I think that there is a device that's designed for each of these anatomic challenges that I set out at the outset. There are multiple options for precise deployment. The sheaths are trackable and flexible. Limb occlusions are far less common with these newer systems, and there are ultra-low profile delivery systems available. There's a broad range of aortic and iliac diameters that can be treated as well. We even have good solutions for up to 90 degrees of neck angulation. But I sort of see an emerging theme. So again, I said from the outset that I was going to try to put this into the context of the evolution of device optimization. And you see depicted here that kind of in the early stages, we were changing around fabric porosity and trackability, really making these devices to be a feasible option compared to open. But more recently, all of the changes have really been optimizations having to do with this proximal fixation and proximal neck length, proximal angulation. So really, to me, the lesson is that the highest priority is optimization of the proximal seal zone. It really has led us to focus more on the long-term drawback of EVAR, which is type 1A endoleak. So it gets into a more philosophical question about whether the goal is to improve infrarenal fixation or extend the seal zone proximally. Baseline aortic anatomy is the key determinant of EVAR planning and technical success. The proximal seal remains the most important factor for long-term durability of aneurysm exclusion. Device manufacturers have applied different philosophies for enhancing durability, and really the question is, should we optimize the infrarenal seal no matter the anatomy, or should we seek a superior seal zone more proximally? Clearly I'm biased, and I will be giving some other talks later on today about fenestrated and branched EVAR. Thank you.